All right, welcome everybody. Part two. So for this part, we're just going to talk about the domain and range of a function. So here, if you don't have it, the domain is a set of, or the domain of a function f of x is a set of x values where the function is defined. So for domain, think x values. For range, think y values. But the range is a set of all values that f takes. Okay. So the idea is, let's take a look at this graph, and we're going to find the domain of this graph and the range. So think domain, x values, think left and right. For range, we're going to think up and down. Okay, so here for domain, when we have our original graph over here, let's take a look. We want to know what are all possible x values. Okay, all possible x values. So let's start. Here, if we have our favorite person in the whole wide world, Mr. Super Mario. Okay, wait, let me get a good camera angle. Okay, good. Here, the question I have for you is, where can Super Mario start, right? For domain, we're going to think left to right. So the question is, do we have x equals -9? That's what you could ask yourself over here. Do we have, question mark, right? Do we have x equals -9? When x is -9, do you have a y value? And what is that y value? It's 1. So yes, you do. So here, we're going to start at, and notice that we're doing question D and E, right? So for -9, let's take a look. Here, we have -9. And, oh, a little something I should have had before, my bad. In our notes, let's just have this very quickly. This idea of, this is inclusive, this is exclusive. So think inclusive, you have it. This exclusive means you don't have it. Okay, don't have it. Okay, and this symbol will be union. Okay, so just have this in your notes very quickly. Okay, so let me, okay, so yeah, take that. So here, notice that, do we have -9? Absolutely, we do. Okay, so we're going to say it's inclusive. And here we're talking about the domain of the function. Okay, so now, do you have x equals -8? Yes, you do. When x is -8, what's the y value? It's -2. Do you have x equals -7? Yes. When x is -7, what's the y value? It's -5, right? It's a closed circle. And notice that you have everything in between. You have everything in between -9 and -8. Everything in between -8 and -7. Yeah? So now let's keep going. Do you have everything between -7 and -6? Yes. -6, -5? Yes. -5, -4? Yes. -4, oh. Do you have everything in between -4 and -3? Yes. But do you have x equals -3? Because at x equals -3, we have an infinite discontinuity. If I said, hey, what is f of -3? What's the y value? It doesn't exist. I'm sorry, it's undefined, right? There's nothing there. So how are we going to say that we have everything in between -9 and -3? We're going to say inclusive for the -9 because we have -9, but we don't have -3. So to say that you have everything between -9 and -3, we're going to have it like this. This means you have everything in between. Now you have -9, so bracket, but you don't have -3, so parentheses. Okay? And this is the idea of inclusive, exclusive. Now what we're going to do is we're going to use that symbol of union to say, okay, we don't have -3, but notice that we have everything to the left of -3. For example, x equals -3.0001, you have this x value. So you have everything to the left of -3, and you also have everything to the right of -3. So like you have x equals -2.9999, you have this x value. You just don't have -3. So to say that you're very close to -3, but you don't have it, we're going to say union parentheses -3. We're going to bridge that connection. Okay? So now that we bridged it, this is saying that you have everything to the left of -3, you have everything to the right of -3, but you don't have -3. So we kind of need to bridge this to this. Now, what's the next part? Do we have -2? Yes. Do you have -1? Yes. Do we have x equals 0? Yes. Do we have x equals 1? We don't have x equals 1 because at x equals 1, we have an infinite discontinuity. So then how are you going to show the next part? Pause the video and try and show the next part before I do. Right? Oh, sorry, this should be a 1. That's a 1. And yeah, here. Okay. And then what's next? Okay. Now, do you have x equals 1? No. Do you have x equals 2? Yes. Do you have x equals 3? Yes. Do you have x equals 4? Pause the video. Do you have x equals 4? If you want to see the video, if you want to continue, what is f of 4? It's negative 1. So you do have x equals 4. It's just not continuous. That's all. But you still have this x value. So notice you have 4. Do you have 5? Yes. Do you have 6? Yes. You have 6. X equals 6. Do you have 7? Yes. 8? Yes. 9? Yes. So then boom, and close it just like that. And that's the domain of the function. You're saying you have all the x values from negative 9 to negative 3, but you don't have negative 3. You have everything in between negative 3 and 1. You have everything between 1 and 9. You have all these x values, okay, because they have a y value in return. Okay, so that's the domain. What's the next part? We got to do the range. So notice that, here, let me put it over here. And notice that this domain is what you would put for over here, right? Now let's do the range. So notice that for domain, we did left and right, correct? We found all the x values. Now for range, we're going to think down and up. We're going to start from the lowest y value to the highest y value. So notice, what is the lowest y value that we have? Do we have negative infinity? No. Negative 8? No. We have negative 7. So let's start at negative 7 and notice you have it, so it's closed. And then you ask yourself, do you have negative 6? Yes, you do. Do you have negative 5? Yes, you do. Do you have negative 4? Yes, you do. Negative 3, negative 2, negative 1, 0, 1, boom, 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 boom. And you have all the y values that keep going up. So the range for the function is negative 3 to infinity. But now the question is it parentheses or bracket? Okay? Remember, if you have bracket, it means you have it. If you have the parentheses, it means you don't have it. So the question is, do you have infinity? Pause the video and think about it. Okay? You cannot hold on to infinity. Like imagine if this is Super Mario and this is infinity, right? The closer and closer Super Mario gets to infinity, the farther and farther infinity goes away. It's like this. You just can't catch it. You can't catch this infinity. You can't hold on to it. So anytime we have some sort of infinity within our domain or range, it has to be exclusive, that you can't hold it. Okay? What I want you to do is, so we did part 1 together for domain and range, right? What I want you to do is try and do part 2, part 3, part 4, the domain and range by yourself, right? Pause the video and try and do it by yourself. Okay. Whew. Okie dokie. Let me zoom in. Who's liking calculus? All right, calculus has been a lot of fun so far. No crying moments yet. All right, where is my pen? Okay, here, let's find the domain. Let's say if you pause the video and you want to check your answers, what is the domain for this graph? So here, let's have some fun. Do you have, I'll say here, capital D, we're talking about domain. Do you have negative 9? Yes, we do. Do you have negative 8? Yes. Negative 7? Yes. Negative 6, negative 5, negative 4, negative 3. Do you have negative 2? No. You have an infinite discontinuity, so we have everything in between negative 9 and negative 2, but we don't have negative 2 union negative 2. Okay? Now let's jump here to the right of negative 2. You have negative x equals negative 1, x equals 0, x equals 1, x equals 2. Do you have x equals 3? Yes, you do. Yes, you do. You have x equals 3. Do you have x equals 4? Yes. Do you have x equals 5? No. You do not have x equals 5. Because if I said, hey, what is f of 5? This is undefined. You do not, oh, sorry. You do not have f of 5. So what we have to do is we have to do everything in between -2 and 5, parentheses, union 5. Okay? Do you have 6? Yes. 7? Yes. 8? Yes. 9? Yes. So 5 to 9 bracket. Okay? For range, let's do the range. Here, we're going to start at -infinity, right? Because that's where this arrow is going. So you start at -infinity, and then this will be exclusive, right? Because you don't have it. Do you have -8, -7? Yes. -6, -5. It looks like you just have all the y values. So this is -infinity to +infinity. And that's the range for the graph. Okay, next one. Number 3. Question 3, right? Okay, here, what is the domain for this graph? Let's take a look. Here, this is domain. So we have -9, -8 we have, -7 we have, -6 we have. Because when x is -6, what's the y value? -6. We have -5, -4, -3, -2, -1. 0, we have 1, we have 2, we have 3, we have 4, we have 5. Oh, just like before, 5 we don't have. So this is -9 to 5 union 5. Okay. So then at 5, do we have 6? Yes. Do we have 7? We don't have 7. So we have everything in between 5 to 7. And then we finish it at 8, we have 9, we have. And that should be the domain. The range, let's take a look at the range. Here, what's your lowest y value? It looks like it's -6. So we have -6. Do we have -5? Yes. -4? Yes. -3? Yes. -2? Yes. -1? Yes. Y equals 0? Yes. 1? Yes. 2? Yes. 3? Yes. 4? Oh, we don't have 4. But we have everything in between 3 and 4, right? From here. So what we're going to do is we're going to say comma 4, but then this part will be exclusive. You don't have y equals 4. Okay? Last one. All right. So here, this is domain. This is range. Okay, so domain is -9, -8, -7 you have, -6 you have, -5, -4, -3, nope. So this goes here, -9 to -3, -2, -1, 0, 1, 2, 3, we don't have, 4, 5, 6, 7, 8, 9. So this is the 9 bracket. Okay. What's the range? It looks like it starts at -7, and it just goes to infinity. Okay, very nice. Happy face. Not too bad, right? Part 1, part 2, not too bad. Okay, so part 3, I will think about how to make this one. Part 3 gets into, because here we talked about the types of discontinuities, right? Part 3 is going to talk about, well, what if we don't have a graph? And I just gave you the function. And I said, hey, where are the discontinuities? What's the domain? How would you be able to figure that stuff out without looking at a graph? Okay, I'll see you soon.